When you first start working on automation with other people, it can feel like everyone is editing the same thing from different angles, and somehow it still needs to come together cleanly at the end. That coming together is where beginners often experience their first real frustration with Git. Merges that suddenly look complicated, conflicts that feel personal, and time lost trying to remember what the change was supposed to accomplish in the first place. Feature branching is one of the simplest ways to reduce that pain, because it creates a deliberate place for work to grow without constantly disturbing the shared baseline. The goal is not to create process for its own sake, but to make changes easier to integrate and easier to review. When feature branches are chosen and used well, they reduce rework because you discover conflicts earlier, you keep changes focused, and you keep the stable line of automation code more predictable. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A feature branch is a separate line of work that holds a coherent change while it is being developed, validated, and prepared for integration. The key word there is coherent, because a branch that collects unrelated edits becomes harder to understand and harder to merge. Beginners sometimes treat a feature branch like a personal junk drawer, but the strategy only helps if the branch has a clear purpose and a clear end state. You can think of it as a container with a label on it, where everything inside serves the same intent. That intent might be adding a new automation capability, improving error handling, or refactoring a component for reliability. When your branch has a focused goal, your commits tell a clearer story, and that clarity reduces merge pain because reviewers and integrators can reason about what is changing and why. Merge pain usually comes from two sources: overlapping changes and drifting baselines. Overlapping changes happen when two branches edit the same areas of code in different ways, forcing Git to ask humans what the combined result should be. Drifting baselines happen when the stable branch keeps moving forward while a long-lived feature branch stays behind. So by the time you merge, the differences are large and tangled. A good feature branching strategy aims to minimize both problems by keeping branches small enough to integrate frequently and by synchronizing with the baseline often enough that surprises do not accumulate. This matters in automation work because changes often interact through shared configuration and shared workflows, even when they look separate at first. If you delay integration too long, those interactions surface all at once, and the merge becomes less about combining work and more about untangling competing assumptions. One approach that reduces merge pain is to make feature branches short-lived by designing work in small, deliverable slices. This does not mean rushing or cutting corners, and it definitely does not mean releasing half-finished behavior into production. It means choosing a feature shape that can be developed, tested, and integrated without needing weeks of isolated divergence. In practice, you separate large ideas into increments that still feel meaningful, such as adding a new capability behind a configuration switch while keeping default behavior stable. That way, the stable branch can accept the structural changes early, and the feature can mature without blocking other work. Beginners often assume a feature must be complete to merge, but in automation, a safer pattern is to merge work that is backward compatible and not active by default, then iterate in additional branches. This reduces rework because you are not repeatedly rebasing or resolving the same conflicts across long spans of time. Another strategy is to keep feature branches close to the main line by regularly incorporating upstream changes while you work. The purpose is not to constantly disrupt your focus, but to reduce the size of the gap between your branch and the baseline. When the baseline moves, it often changes shared utilities, dependencies, or patterns that your branch also relies on. If you wait until the end to catch up, you may find that your branch assumptions no longer match reality, and then you have to redo work to fit the new shape of the codebase. Regular synchronization helps you adjust gradually, which is easier than doing it all at once. In automation projects, this is especially valuable because the baseline might change due to urgent fixes, dependency updates, or security-driven adjustments. Keeping your branch aligned means you detect those changes early and adapt with smaller, clearer edits. Feature branching also reduces merge pain when it is paired with a clear definition of what belongs in a branch and what does not. A branch is not just a place to put code. It is a unit of integration, which means it should contain a set of changes that make sense together. If you mix formatting changes, dependency upgrades, and new functionality in the same branch, you create a merge that is harder to review and harder to diagnose when something breaks. A clean strategy is to isolate concerns. Let the branch represent one primary goal and keep unrelated work in separate branches. This does not create extra work. It saves work because reviewers can focus, conflicts are narrower, and rollbacks become more precise. In deployable automation, precision matters because you want the ability to undo a risky change without undoing unrelated improvements that are already proven safe. The human side of merge pain is often about understanding intent, which is why branch naming and scope discipline matter even before you think about remote collaboration. If someone reviews a feature branch and cannot quickly grasp what it changes, they will either miss important details or request rework simply to make the change understandable. Merge pain is not only about Git conflicts. It is also about cognitive conflicts, where people interpret the change differently because the branch contains multiple purposes. A well-scoped branch reduces that cognitive load because it has a single narrative, and that narrative shows up in commit messages, file changes, and the overall diff. For beginners, this is a powerful lesson. Clarity is a technical feature. It makes integration easier, reduces back and forth, and helps the team keep the automation codebase stable under constant change. Feature branching strategies also differ in how they handle partial progress, and this is where beginners sometimes create accidental instability. If you commit half-finished work directly to a shared branch, you may break the codebase for others, even if you intended to fix it later. A feature branch solves that by giving you a safe place to record progress without forcing it into the shared baseline. At the same time, you still need discipline inside the branch, because the branch history is what you will eventually merge. A helpful mindset is to keep the branch in a state that is internally consistent, even if the feature is not finished. That means avoid committing changes that leave the code obviously broken, and when experimental steps are necessary, keep them small and quickly corrected. When the branch remains coherent, merge becomes less stressful because you are not merging chaos. You are merging a series of understandable steps. There is also an important relationship between feature branches and review, because review is one of the best tools for reducing rework. If a team can review a branch while it is still small, they can catch misunderstandings early, before the work spreads into many files and many assumptions. This is especially true in automation, where a small misunderstanding about error handling or configuration semantics can lead to major runtime issues later. A good feature branching strategy encourages early review by making branches small, focused, and easy to understand. It also supports incremental review, where a branch can be refined through feedback without dragging the baseline into constant instability. Beginners sometimes think review is a final hurdle at the end, but in practice, review is a learning loop, and feature branches are the container that makes that loop manageable. Another way feature branches reduce merge pain is by making conflicts more predictable. Conflicts are not random. They happen when two changes overlap in text or intent. If you keep feature branches narrow and integrate frequently, conflicts tend to be smaller and more local, which makes them easier to resolve correctly. If you keep branches long-lived and wide in scope, conflicts tend to be broader and more conceptual, which makes them harder to resolve without rework. In automation projects, conceptual conflicts are especially dangerous because they can produce a merged result that compiles and runs, but behaves incorrectly under real conditions. Small, frequent integration helps you notice when two efforts are drifting toward different designs and forces that conversation earlier. That earlier conversation is often what prevents rework because it aligns design before code becomes too entrenched. Feature branching also interacts with stability expectations, and this is where predictable delivery connects back to branching choices. If your team has a stable branch that is used for releases or deployments, feature branches act as a buffer that protects that stable line. The buffer matters because automation is often tied to schedules, pipelines, and operational commitments. If the stable branch becomes unreliable, teams lose confidence and start pinning to old versions, which creates fragmentation and complicates security fixes. A good feature branching strategy keeps the stable line clean by ensuring that only reviewed, integrated, and coherent changes reach it. That does not slow down learning. It speeds up delivery over time because fewer emergencies are caused by accidental instability. Beginners should recognize that stability is not the result of one big safety step at the end. It is the result of consistent containment and integration choices throughout development. It is also worth discussing how feature branches can be designed to reduce the cost of merging by limiting the surface area of change. The surface area is not just the number of lines changed. It includes how widely the change touches the codebase and how many other parts depend on it. If a feature branch changes core shared utilities, it will likely conflict with many other branches because many other branches rely on those same utilities. Sometimes that kind of change is necessary, but a strategy to reduce pain is to separate foundational refactors into their own integration work, so feature branches can build on a stable foundation rather than each branch reinventing it. In other words, if the plumbing needs work, fix the plumbing in one focused effort, then let feature work proceed on top of it. This reduces rework because you do not end up resolving the same foundational conflicts in multiple branches. From a beginner perspective, a practical way to choose a strategy is to match branch design to the risk and coupling of the work. If the work is highly coupled to shared components, you want tighter integration and smaller branch scope because divergence will create conflicts quickly. If the work is more isolated, you can afford a slightly longer branch, but you still benefit from keeping it focused and synchronized. The key is to avoid the extreme of long-lived branches that quietly drift away from the baseline while the rest of the team moves forward. Those branches often feel productive while you are inside them, but they create a painful merge event later that eats the time you thought you were saving. In automation code, where reliability and clarity matter, that delayed cost is especially expensive because it tends to arrive right when you want to release or respond to an operational need. When rework happens, it is often because the branch does not reflect reality anymore, either because requirements changed, dependencies changed, or the baseline evolved in a way the branch did not anticipate. Feature branching can't prevent change, but it can reduce the cost of adapting to change by keeping work in manageable units. If the branch is small, you can adjust it quickly. If the branch is large, adjusting it becomes a project of its own, and that is where teams lose momentum. This is also why clear branch boundaries help. When each branch has one goal, you can decide whether that goal is still valid and either finish it, reshape it, or abandon it without dragging unrelated work down with it. That flexibility is a major advantage in automation work, where external systems and priorities can shift quickly. As you build maturity, you start to see that feature branching strategies are less about strict rules and more about consistent habits that protect the team from predictable failure modes. Keep branches focused, keep them short-lived when possible, sync often enough to avoid large divergence, and avoid mixing unrelated concerns that confuse review and integration. Use the branch as a communication tool, not just a storage place, so others can understand what is happening and why. Protect the stable line so deployable automation remains trustworthy, and treat integration as a normal, frequent activity rather than a dramatic event. When you choose strategies like these, merge pain becomes a smaller, more manageable part of the workflow instead of a recurring crisis. That is the real definition of reducing merge pain and rework, not eliminating complexity, but containing it so the team can deliver predictably without burning time on avoidable conflicts.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.